Our topic today is expanding brackets. We're going to start a little differently today. We're going to start with the diagram that I want you to think about. So let's say that I had a plot of land. This distance is B. We don't know how far it is. This distance is is 5. This distance is A. We also don't know how far that is. And this is 10. We don't know how far that is. Now you do know how to do the area of a rectangle. So let's talk about this. Now we could express this in several different ways. One way that we might do it would be to say we add up these three rectangles. This one, how do we get the area of a rectangle? Length times breadth. So we have A times B, which is AB. Then we have this one, which is 5 times A, so we're going to add 5 times A. And then this one is 5 times 10, which is 50. So that's one way that we could express the area of that. Another way that we could do it is we could take this entire rectangle at one time. So we could say this full distance is what? It's A plus 10. And we're going to multiply that times 5, because that's this, plus this box that I left out, which is AB. Or we could look at this area. That means this length is 5B, 5 plus B. And we're going to multiply it by that, which is A. And then we have this rectangle here, which is 50. A fourth way that we could look at this is we could take the whole thing, and we could say it's 5 plus B, that's this, times that, times A plus 10, and then I'm going to take out this. I'm going to subtract 10B, which is the size of this. Okay? Now, the reason that we're looking at these is because what we're trying to do is expand brackets. And another term that means the same thing is removing grouping symbols. Okay? Now this last example, while it's accurate, is one that might confuse us a little. It's something we'll deal with later. So we're not going to be concerned with this one right now. But we do want to look at these others. And what we have to use is what's called the distributive law. Now you've probably used the distributive law in your heads on a number of occasions, even without realizing it. But the distributive law says this: A times B plus C is equal to A times B plus A times C. And we can do the same thing in the middle with subtraction. So A times B minus C, different problem, is equal to A times B, AB, minus, because there's a minus in the middle, A times C, or AC. That is the distributive law. And as I said, it works either way with subtraction or addition. Now I want you to think for a minute about how this would work. Let's say, we're going to simplify our picture just a little bit. Okay? Let's say that we just had a rectangle that looked like this. Now, how would we describe the area of that entire rectangle? Well, we would say it is 5 times A plus 10. Now, if we knew what 10 was, let's say we knew that what A was. If we said that A was 2, then we have 12, and we could multiply that by 5 and get 60, and that would be great. But we don't know what A is. So what can we do? Well, we can multiply this. 5 times A gives me 5A. And 5 times 10 gives me 50. Okay, so we take what's in the front and we multiply it times each of the things inside the brackets, and in that way we can get rid of the grouping symbols. And if you look at the examples that I've done up here and think about them a little bit, how would that work? In this situation, which is the same as that one, 5A plus 50 plus AB, and we have the same answer as we started with up here. AB plus 5A plus 50. This one works the same. If I multiply here, I get 5A plus AB plus 50. And again, different order, but it's the same thing as I started with at the top. Let's do some examples and see if you can figure out how these work. I'm going to take this off just so we have some room to work. 3, 2x plus 5. What are we going to do? We're going to multiply the 3 in. And we multiply because the 3 is multiplied by what's inside the brackets. So we're going to do 3 times 2x, which gives me 6x, plus, and then we're going to multiply here as well. 3 times 5 is 15. Now, we can also do something like this. What if it has a minus 8 out in front? Same idea. Minus 8 times 7 gives me minus 56. Multiply here. Plus minus 8 times 2y is minus 16y. And we're done. As you know, if you wanted to, you could rewrite this minus 56 plus a negative is the same as minus a positive, and you could write it that way. In the test, either one of those would be satisfactory. Another example. What if I have a pronumeral out in the front? Like 4x. Still works exactly the same. We multiply here. 4x times 2x is 8. X times x is x squared, minus, and then we do the multiplication over here. 4x times y is 4xy. We're done. Now, sometimes you have a problem that requires one more step. Let's take, for example, this problem. 3, 2b, 5. Now, in this one, I'm going to write it underneath so you can follow it a little bit better. What do we do here? We multiply. We get 3 times 2b is 6b, plus, times, 3 times 5 is 15. Now, we've removed the grouping symbols, and what do we have left? We have 3b left. Now, we also have now two terms that are like terms. We have 6b and 3b, here and here. So we can simplify by putting those together. 6b's, 3b's, 9b's, and 15. So in this problem, we have to simplify after we multiply through the terms, after we remove the grouping symbols. One more example, 12xy plus 7x times 2 minus y. Now this one, I have 12xy out in the front. Whoops, use the other pen. 12xy, which I'm not going to do anything right now with. I need to remove my grouping symbols. So I'm going to multiply here. 7x times 2, 14x. Now this minus, so that goes with the y. Minus 7x times y, 7xy. And I multiplied there. Now again, I have two like terms. This one is xy, this one is xy. This is only x, not the same pronumeral raised to the same power. So I can put these two together. 12xy minus 7xy gives me 5xy plus 14x. And that is expanding brackets.